Hey guys, welcome back to OTUI Institute. And today we'll be going over Chapter 9 Applications of Integral. So, the first thing is volume by slicing, which is suppose a solid object extends from x equals a to x equals b, and the cross section of the solid perpendicular to the x axis has an area given by the function a of x that is integrable on a to b. The volume of the solid is v equals integral of a to b a of x dx. So what this means is that the volume is the integral of the area. Like example 1, the region R is formed by y equals square root 1 minus x squared and the x-axis. Find the volume of the solid with base R whose cross-sections perpendicular to x-axis are squares. So using that formula, v equals integral a to b a of x squared dx. So our boundaries right here are -1 to 1 because that's what the area and volume is enclosed by. So then our area, the formula for the area is f of x squared. And the f of x is root 1 minus x squared. So we're going to square that root 1 minus x squared, which gets us here. And then we take the integral, and then we get x minus x cubed over 3 with the bounds -1 to 1. Plug those boundaries in, you get 4 over 3. Our next concept will be the disk method. Let f be continuous with f of x greater than equal to 0 on the interval a to b. If the region R bounded by the graph of f, the x-axis and the lines x equals a and x equals b is revolved about the x-axis. The volume of the resulting solid of revolution is, we have the formula v equals integral a to b pi of f of x squared dx. And what that f of x is, it is the radius. So what I'm talking about with the radius is, let's say we got our equation f of x, which is right here. And then it's revolved about the x-axis. The x-axis is right here. Our radius is the distance between these two lines or curves, which is right here. And that's what the radius is. So what this formula is volume equals integral a to b pi times the radius squared dx. Example 2. The region bounded by the graph of y equals x, the x-axis, and x equals 1 is revolved about the x-axis. Find the volume of the resulting solid of revolution. So with the same formula, v equals integral a to b pi f of x squared dx. So first, our a to b bounds, that is 0 to 1, as this is where the boundaries where the lines enclose to form the area and volume. 0 to 1. Our pi is there, pi. And then our radius is our x minus the x-axis, which is x equals 0. So that gives us x minus 0, which is x. So, and then pi times the radius of x squared. So that's where we get pi x squared dx. Let's take the integral 1 over 3 pi x cubed with the boundaries 0 to 1. Plug those boundaries in, 1 over 3 pi. Now we have the shell method. Let f be continuous with f of x greater than equal to 0 on the interval a to b. If the region R bounded by the graph of f, the x-axis, and the lines x equals a and x equals b is revolved about the y-axis. The volume of the resulting solid of revolution is volume equals integral a to b 2 pi x f of x dx. So the big difference between this shell method and the disk method is that the shell method is for revolved around the y-axis, and the disk method is revolved around the x-axis. So whenever the question says revolved about the y-axis, use the shell method. If it says revolved about the x-axis, use the disk method. So now into the formula, your volume, your boundaries a to b, 2 pi x, and then the f of x, as same as before in this method, is your radius. It's what we talked about before, the radius. Example 3. The region bounded by the graph of y equals x squared, the x-axis, and the lines x equals 0, and x equals 1 is revolved about the y-axis. Find the volume of the resulting solid of revolution. So now, as a refresher, the volume formula is equals to integral a to b 2 pi x f of x dx. Now here our boundaries are 0 to 1, as it says x equals 0 and x equals 1. This is our bounded. So that gives us 0 to 1. 2 pi x is part of the first part of the formula. And then x squared. This, our f of x, our radius here is x squared dx. Because let's say you draw a graph. Okay, let's do it over here. X squared is this. The x-axis is right here. X equals, I meant the y-axis, my bad. The y-axis is here. X equals 0, and then x equals 1 is right here. And then, oh no, it does say the x-axis. So the x-axis is this. X equals 0 is here, and then x equals 1 is here. So where is the radius? Is the distance between here to here, which is x squared minus 0, which is still x squared. And that's how we got the radius of x squared. You take the integral, which is 1/2 pi x to the power 4, bounded 0 to 1, plug that in, 1/2 pi. Now, example 4. The region bounded by the graph of y equals e to x, the y-axis, and the line y equals e is revolved about the y-axis. Find an expression of the volume of the resulting solid of revolution. So you can use the disk method or the shell method, but if you use the disk method,